All right. Does anybody have a question?
I do. When is the final exam starting? Like, what time does it start?
It's on the 29 at 8 a.m.
Okay. And we're joining the Zoom call as usual for that?
Yeah.
Okay, thank you.
Welcome.
Is
Any
it
other?
going to be equal parts from the four tests on the final exam?
The final exam is going to be a mixture of questions from the 4 tests that you have. The important thing is make sure you are able to answer those things. Some of them might be combined, so there's no knowledge as to how much is going to be from each of the tests. Usually they are roughly equivalent.
Do you mind going over divergence tests and whether something is monotonic or not?
Give me an example. First of all, the divergence test is used only to decide that a series is divergent. So the two things, when do you use it? You say when a series diverges. How do you use it? When the limit of an is not 0 or does not exist, the sum of an diverges. That's the divergence test. Let's say we take a series like this. Obviously, for this series, an equals cosine of pi n. And cosine of pi n doesn't have a limit. As n goes to infinity, this thing does not exist. Why? Because if you plug in an even number, you get 1. If you plug in an odd number, you get -1. So this function is either 1 or -1, and they repeat 1 minus 1, 1 minus 1. It's never going to give you a limit. So because that limit does not exist, we would say that the sum n from 1 to infinity of cosine pi n diverges. That is using the divergence test. Or you could say sine of n over n here an is sine of n over n if you use the squeeze theorem, you would see that absolute value of an less than 1 over n, because sine of n is bounded by 1, and limit of 1 over n goes to 0. So limit of an is equal to 0. And because the limit of an is equal to 0, you can't use the divergence theorem. Because the question, when we had it, we said, when do we use it? When it diverges. And you need to know that limit of an is not 0. Here you got a limit equal to 0, so you can't use the divergence theorem on that. Other questions?
I know it's not the same thing, but can you go over monotonic functions as well?
Monotonic sequences. So a sequence is monotonic if and only if it is either non-decreasing or non-increasing. So a non-decreasing sequence is one in which an plus 1 is larger than or equal to an. Non-decreasing, so it doesn't decrease. And non-increasing is when an plus 1 is less than or equal to an. So if you want to show that a sequence is non-decreasing, you want to show this. If you want to show that a sequence is non-increasing, you want to show that. In a particular case, when let me put that there, when an equals f of n, when an is f of n, where f is a function that is continuous with a derivative, here non-decreasing would mean f prime of n larger than or equal to 0 for n larger than a given threshold. And here that would mean f prime of n less than or equal to 0 for n larger than a given threshold. So in general, that's the definition. In particular, when you can write an as a function that has a derivative, then if the derivative is positive, you conclude non-decreasing. If the derivative is negative, you conclude non-increasing. Else, you use the definition to show that an plus 1 is larger than an, or an plus 1 is less than an. This here is same as an plus 1 minus an larger than 0, and this is an plus 1 minus an less than or equal to 0. So you need to either do this computation or do that computation. Sorry, to either do this computation or do this derivative, depending on the case. Now, example. An equals, say, 1 over n factorial. Let's say we give you this. I mean, even to make it more interesting, let's say we do this. 2 to the power n over n factorial. Now, in here, you can see that you don't have a form of a function that you can take derivative of, because we can take derivatives of factorial n. So we have to do this computation to figure out whether it is increasing or decreasing. And so to answer the question, you're going to have to find an plus 1 minus an. An plus 1, replace n by n plus 1. At this point, we must know this already. Minus an, that's 2 to the n, over n factorial. And now the rest is your knowledge of calculus, how you simplify this to see whether it's positive or negative, because you need to decide whether this difference is positive or negative. And you check. Here I got 2 to the n, 2 to the n. Factorial n plus 1, there is a relationship with factorial n. So this is 2 to the n times 2 over n plus 1 times n factorial, because that's what factorial n plus 1 is. And I do this to simplify 2 to the n over n factorial. And the point here is not for you to memorize what I'm writing down, but to understand what the principle is, because it's not the same question you're going to see. You need to know what the principle is, what we are looking for, and why we are doing these steps, right? So here, what you get, we can factor out 2 to the n over n factorial. We're going to be left with 2 over n plus 1 minus 1, which is 2 to the n over n factorial, times this is 2 minus 1, 1 minus n over n plus 1. Now you can see with this computation that this number is less than or equal to 0 as soon as n is larger than 1, right? Is that making sense?
Yeah.
Yeah, so as soon as n is larger than 1, this thing is negative, this is positive, so the whole thing is negative. And this 1 is the capital N that you have here. So as soon as n is larger than 1, the difference is negative. And because that difference is negative, that means an plus 1 is less than or equal to an. So the sequence is non-increasing, right? Because it is less. So it's this case. It's either that or this. We found less, so it's this case. It's non-increasing. And if it's non-increasing, it's monotonic. Let's say now we have this an. In this one, you can see that you have a function that you can take derivative of, a continuous function that has a derivative. So you will have a different answer than the one we just wrote. You can still try to do that. You waste more time. In this particular case, when you find a derivative, it's easier, a lot easier. So that's n squared plus 1 minus 2n squared over n squared plus 1 squared. Of course, easier if you know how to take the derivatives. So now that's 1 minus n squared over n squared plus 1 squared. And again here, you see that this is negative as long as n is larger than 1. So an is non-increasing also. Questions? Any questions on this?
Not on, this isn't, I understand the monotonic stuff now, but for polar coordinates and graphing the cosine data functions, would you mind doing a problem on that?
Give me an example.
R is equal to 1 plus cosine 4 theta.
So here you have polar coordinates, graphing, area, So these are all the topics that are related to that, polar coordinates. You had graphing, you had to compute the area, and then you had to find tangent lines. And you just gave me an example. R equals 1 plus cosine of 4 theta. Of course, let me take theta. 0 to pi, and then I want you to give me the tangent line at theta 0. Tangent line at theta 0 equal here pi over 6. Now question, first part, let's say, sketch the graph. How do we sketch the graph of this? What are the steps that I propose for this?
Don't you find where R is equal to 0? You find the points.
Yeah, and then?
Solve for F theta equal to 0.
Yeah, that's the first one. What's the other step?
R prime.
R prime equals 0. So these are the two things that you need to solve. You need to solve for R equals 0, and then solve R prime equals 0, find all those angles and try to use them to sketch the graph. Thanks. So here, when you say R equals 0, that means 1 plus cosine 4 theta equals 0. That means cosine 4 theta is -1. And -1 is the cosine of pi. So you get 4 theta is pi plus 2k pi. And this is trigonometry. You need to know how to solve trigonometric equations. So this one, for -1, it's plus 2k pi. And then from there, you can solve for theta, which is pi over 4 plus k pi over 2. And then you list all the angles that are from 0 to 2 pi using various values for k. When k is 0, we get pi over 4. When k is 1, you get pi over 4 plus pi over 2, that's 3 pi over 4. When k is 2, you get pi plus that, so that's 5 pi over 4. When k is 3, you get 7 pi over 4. That is still less than 2 pi. And when k is 4, you get 2 pi plus. So it's larger than 2 pi, so you don't want to get there. So that's it. You have 1, 2, 3, 4 numbers. So there are 4 angles along which the radius comes back to 0. That's what it means. Because at those points, the radius is at 0. Now, we want to find r prime equals 0. This is to figure out where are the points where the radius is possibly maximal before it starts reducing to go back to 0. So you take the derivative of that, it's negative 4 sine of 4 theta equals 0. You solve this, you get sine of 4 theta equals 0, and that gives you 4 theta equals, what are the angles that have sine equal to 0? Hello?
0 is one of them.
Is it the only one?
Is pi one of them as well?
Is it the only one? You need to solve the way the other one was solved. It needs to have a k in there.
Would it be 0 plus k pi then?
K pi, that's it. That's how you solve a sine equals 0. And now you're going to solve that. You're going to get theta equals k pi over 4. So here, you start plugging in those values. Theta equal, you got 0 for the first one, pi over 4. Pi over 2. And then 3 pi over 4. And pi. And so on. So then you get 5 pi over 4. 3 pi over 2. 7 pi over 4. So you get a lot more. 1, 2, 3, 4, 5, 6, 7, 8. Right. Now notice one thing. These numbers are here as well. 3 pi over 4. 5 pi over 4. 7 pi over 4. Pi over 4. What does this mean?
Is that where the slope of the graph is equal to 0?
Yeah. Where the derivative is equal to 0 is potentially where the radius is reaching its local max or a local minimum. Now what this is saying is that all those points include the points where the radius is getting back to 0. So it's actually getting back to 0, and that 0 seems to be a local max. So it's kind of coming back to 0 and coming out right away. not continuing to go in the negatives, but turning to be positive. All right, so, and now you want to draw that graph. What is it going to look like? You just draw one piece of it, okay? Let's draw it from 0 to pi over 2. So just this piece. To do that, we want to put in all the angles that are in the region from 0 to pi over 2. And those angles are 0, that's right here already, pi over 4. So pi over 4 is half of this. So that's the angle pi over 4. And then pi over 2 comes this one. And 3 pi over 4 is already out of here. So we are only concerned by these guys and that one. And in that region, there is only one point where the radius comes back to 0. It's pi over 4. But after getting back to 0 there, it pumps back up to get to pi over 2. That's what it says. Now you get the radius. So what is r of 0? It's 1 plus 1, 2. So when we start, we are right here because r of 0 is 2. What is r of pi over 4? R of pi over 4, the problem already tells you it's going to be 0, right? So by the time we reach pi over 4, the radius goes back to 0. And when you reach pi over 4, the radius gets to 0, but what happens? It goes back up because after pi over 4, the radius was 0 here, 0, but we have a local minimum here because r prime is equal to 0 there, right? So it gets to 0 and it pumps back up and it goes in the direction of 3 pi, it goes to the direction of pi over 2. So we get r of pi over 2. What is it equal to? 1 plus cosine of 2 pi, it's 2. So it gives you 2. So when we return to pi over 2, we are reaching again the maximum. So we start here, we hit pi over 4 here, and we hit back pi over 2 there. So this radius started somewhere here, decreasing, getting here, but it doesn't get here as we think it's going to get. Why? Because when we get to pi over 4, what's the radius? We start this. Go to prime. And here we finish like this. And now it's going to continue on the other side. Are we good?
Yes.
Now, like I said, I just needed that piece. And then in the second guy, we want to find equation of a tangent line. At theta 0 equals pi over 6. And that's where you need to remember that x equals r cosine theta, y equals r sine theta. So you can write this as x equals cosine theta times 1 plus cosine 4 theta, y equals sine theta times 1 plus cosine 4 theta. And then you find x of pi over 6, that's cosine pi over 6 times 1 plus cosine of 2 pi over 3. How much is this? What's the cosine of pi over 6? I'm guessing this is root 3 over 2 times 1 plus, and cosine of 2 pi over 3, it's minus 1/2. So this is root 3 over 4. And you got y of pi over 6 equals sine of pi over 6 times 1 plus cosine of 2 pi over 3. And same as there, the sine here is 1/2. And the other guy is same, 1 minus 1/2. So it's 1/4. And then you gotta find x prime as well. The derivative is gonna be here minus sine theta times 1 plus cosine 4 theta minus 4 sine 4 theta cosine theta y prime of theta equals cosine theta times 1 plus cosine 4 theta minus 4 sine 4 theta sine theta. And then you find the value at pi over 6. And here again, everywhere that's 1 plus cosine 4 theta, 1 plus cosine 4 theta, we already know this is 1/2, right? And the sine of theta, so this is negative sine of pi over 6. Sine of pi over 6 is 1/2, and 1/2 times 1/2, that is 1/4. So that's minus 1/4 minus, and here the sine of 4 theta, so that's going to be sine of 2 pi over 3, which is same as sine of pi over 3. And the sine of pi over 3, how much is it? 1/2. So minus 4 times 1/2. And the cosine of pi over 6 is root 3 over 2. Again, here this is root 3 over 2 times 1/2. This is root 3 over 2. This is 1/2 minus 4 sine. That's the same guy that is there. So that's 4 times 1/2 times sine theta. Sine of pi over 6 is 1/2. Okay. So this guy here is minus 1, and this is root 2 over 4 minus 1. And that one is why is that root 2? That's root 3, right? And then here we got minus 1/4 minus root 3. So we got those numbers, and the equation of the tangent line, what is it? It's y minus y0 equals m times x minus x0, where m, which is the slope, is equal to y prime pi over 6 divided by x prime, that's pi over 6. So y0 being the value of the function and x0 being the value of x. So that's y minus y0, value of the y, it's 1/4, equals m y prime, this is the number, root 3 over 4 minus 1 divided by minus 1/4 minus root 3 times x minus x0, which is the value we found here, root 3 over 4. And you can simplify from that point if you want. It's not something that you must do. Any questions? Hello?
I don't have any more questions.
Anybody else? Find the area of one loop of this curve. You have the formula of the curve. Give me the area of one loop. 5 minutes. as an answer?
I have an answer.
Okay, so first of all, what would be the range used for one loop here?
Would 0 to pi over 4 work?
One loop should be a complete closed piece of the graph, going from one point and returning to the same point.
Okay, so then would pi over 4 and then 3 pi over 4 work?
2 consecutive points, yeah. 2 consecutive points where you go from 0 back to 0. From pi over 4 to 3 pi over 4, you go from 0 to 0. And that's one time. So you don't do that twice. So that's good. So first of all, a loop is from pi over 4 to 3 pi over 4. It's not the only loop. There are many of them, but the area is going to be same no matter which one you choose. And how do you compute the area?
With the integral 1/2 from the first point that you choose to the second point that you choose. And then in this case, it would be 1 plus cosine 4 theta d theta.
Is that?
Yeah, and then with a d theta at the end.
Something missing. What's the formula?
Squared.
Squared. That's how you do. And so that is 1/2 integral pi over 4 to 3 pi over 4. And then you open these parentheses, that's 1 plus 2 cosine 4 theta plus cosine square 4 theta d theta. And that's going to be 1/2 integral 0 pi over 4 to 3 pi over 4. This is going to be 1 plus 2 cosine 4 theta. And then you use the double angle formula to get this thing as 1 plus cosine of 8 theta over 2. This is equal to that, so you replace that here. D theta. Now you can say 1/2 here, 1/2 here, that's 1/4 integral from pi over 4 to 3 pi over 4. That will be 3 plus 4 cosine 4 theta plus cosine 8 theta d theta. So 1/4 3 theta minus sine 4 theta when you integrate this and here. Well, that's plus, right? Because we are integrating. When you integrate this, you get sine 4 theta. When you integrate that, you get 1/8 sine of 8 theta. And then you plug in pi over 4, 3 pi over 4. And so this is going to be 3 pi over 2 for the first one when I integrate, when I plug in the 2. And for this one, 3 pi over 4 times 4, it's going to be sine 3 pi 0, that's 0, 2. So it's plus 0. And this one is going to give you 0, 2. Because sine of 2 pi is going to be 0 and sine of 6 pi is going to be 0. So your answer that you get is 3 pi over 16. Is that correct? I'm guessing 8 because here 3 pi over 4 minus pi over 4, that's pi over 2, right? So that's 3 times pi over 2. And then I'm plugging in 3 theta. 3 pi over 4 minus pi over 4, that's pi over 2 times 3. Any questions on this? All right. The next thing is find the limit when n goes to infinity of 1 minus 2 over n to the power 3n. And that is required to use all the details that we provided solving this problem, not just write down one formula. 5 minutes. And work this out with me, Matthew.
Yeah, I can do that.
Let's go ahead.
So you replace n with infinity, and then you get 1 minus 2 over infinity is, and that's equal to 1 to the power of infinity, which equals 1.
All you say is correct, except that 1 to the power infinity is not 1. It's a non-determinate form.
Oh,
There's only one way you can answer this one. Can I give it a try, Eric?
Sure. Don't use the root test.
It's not testing. It's not 6 series. It's find the limit. Nick?
This is where you have to translate the problem into a log, right?
Yeah, that's the only step that you have to do there. So what do you get? You turn the problem into a new one, taking natural log of what you have. If you call this an, and that's going to be 3n natural log of 1 minus 2 over n. And right there you can see why 1 to the power infinity is not 1, because this is natural log of 1, it's 0 times infinity, and 0 times infinity is undetermined. That's the reason why you need to do that natural log. And now the next thing you need to do inside when you're computing the limit of this bn, what is it? If we already know that it's infinity times 0, which is undetermined, what should we do?
Would you take the derivative of it?
You can't just take a derivative. It doesn't, that's not the rule here.
Or would it be L'Hopital's rule then?
There's no L'Hopital's rule when you have just one function. To do L'Hopital's rule, you need a ratio of two functions which have the same limit equal to 0 or infinity. So what's the next thing we do here? Gauge. Is Gauge here? Sydney.
I'm trying to look in my notes what to do, and I don't know.
Do you figure out what needs to be done, Nick?
You have to make it into a function with e. So change the natural log so that it has e as a base.
We can't change back to that because that's where we started.
I found an example in my book, but I don't know if it's right. And it does the derivative over the original function.
That's not what we do in this step. And the answer is in what I said earlier. You can't do L'Hopital's rule unless you have a ratio of two functions that have the same limit, equal to 0 or infinity. And I'm not seeing the ratio you're talking about here. Did you find that, Nick?
No, I haven't found it yet.
It is in those notes. The step to follow is to get the ratio of two functions with the same limit. Now you have 0 over 0 when you plug in the numbers. And that's where you can do L'Hopital's rule, because you have a ratio of two functions that have the same limit equal to 0. That's the derivative of the top function, and that's the derivative of the bottom. And that's what you get when you do that. And now that's going to be 6 over 1 minus 2 over n. And that limit is 6. And I'm losing this minus. So minus 6, and that limit is minus 6. Therefore, limit of bn equals -6. So limit of an, which is e to the limit of bn, is e to -6. You can find that question as well on your test one. The last thing to remember here would be, how do we do the ratio test? First of all, you need to have positive numbers, and you need to have an plus 1 over an. Find this limit as n goes to infinity to be L. L is less than 1 would imply that the series converges. L larger than 1 would imply that the series diverges. And L equal to 1 would be inconclusive. Then we had what we called the ratio test, the root test. Where you still have some of an with an positive, and you want limit as n goes to infinity of the nth root of an equals, let me call this r. If r is less than 1, the series converges. If r is strictly larger than 1, the series diverges. If r equal 1, again inconclusive. And then we had the integral test, still for sum of an. This time an is f of n, where the conditions are that f is continuous, f is decreasing, and then if you figure that so limit of, I wanted to put limit of an, but we don't really need that here. Integral of f of x dx from a to infinity, and the sum of an converge. Here I'm gonna say f positive as well. Converge or diverge simultaneously. Now it's the one thing. And the other guy next to that was the alternating series. Where you had all those. F is an positive, an decreasing, and limit of an equals 0, then sum n from 1 to infinity, negative 1 to the power n, an converges. That's what we have here. On top of all that, from here we had Taylor series. Okay, that's it. So thank you for coming today. I'll be hoping that we meet next week. Your exam will cover all the things that you have on your 4 exams. Supposed to be 3 to 3.5 hours. So you have more than enough time to answer all the questions that you have there. You just need to be prepared for your exam. If you're not prepared, then obviously it will look difficult. If you are prepared, then you can do it in like half of the time that will be assigned for it. Thank you very much for taking the course.